All right, so we're back and we're looking at weekly sales now. So the average weekly sales for Abercrombie and Fitch between 2004 and 8 are given below, and so we have, these values here. What behavior suggested by a scatter plotted data indicates that a quadratic model is appropriate? So if we plot this, we will find that we get a scatter plot. So let's go to our calculator and see what we get. All right, so we come over here and we look at our plot, and it's coming up and reaches that max, then changes directions and comes back down. Okay, and that's what it's looking like. So that's a quadratic. We have increasing concave down, and so that's going to be kind of what we're seeing there. Now remember, this one, it asked for us to say and set time equal to 0 to 2000. So the data table is 2004 to 2008, and so those values are going to be 4 through 8. All right. So basically, our single concavity and it's down, so that's going to be our quadratic. Now it says actually find that quadratic function, and so we go to 5, and if we want, we can go ahead and view it in here. But first, I'm going to write that down into my table, because this, if we go over here to our Excel table, is going to be the value I plug in here. And I'm going to use all the data points, decimal points here that they give us. And so, it's going to go out to the 2.814285714. And if we go back over here, that's exactly what I have right there. I'm going to go all the way and get clear to the end, and then t squared, and then plus the 41 da, 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 times t minus da, 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 the whole thing. All right, so now we can go back and let's make sure our graph has the quadratic. So that's what it looks like. It's not a very good fit, but it's still quadratic in nature. So the function we have and what we're going to play with is this one. Okay. Now it says, so what we've done is we've done part A, and so part B, we've done that too. We've got our quadratic formula here. Now part C says estimate the derivative of the model from part B in 2007 to the nearest $100. All right, so what we're going to do here is um, uh, put in our numbers. 7 is going to be our limiting factor. So we're going to go 7 from the left, 7 from the right. So 6.9, 6.9999, all the way down, then 7.1, so on. And then we plug in this whole function here, and we're going to use A2 in this case for this model. And then with this one, we'll use A3, which is the 6.99, and we'll get all of our f of x's. And then we can take f of 7 minus f of x divided by 7 minus the 6.9, and that's what's going to be in this thing. We're taking our model, plugging in the 7 and a 7 here, subtracting off our f of x, which we found already by plugging in the 6.9, and then we're taking 7 minus the 6.9, and then we get this value. And again, we're just going to copy down. So, initially we could be given just those first two. We don't have those, and we just highlight them, and then we say Control D, and we get all our values there. Okay, and so that's another function. I'm sure if you've been doing Excel for a while, you know that is. All right, so it looks like if we're doing this is in, let's see, $1,000, and so hundreds of dollars, that means it's going to be to the nearest one decimal place, because if we think about this, let me see if I can do an inking here. Yeah, so if we have $2,500, that's 2,500, and we're looking at this as thousands, that's going to be 2.500. And so what's the nearest hundred? Well, it's going to be to the nearest one decimal place. And so I took and said, well, these are all the same, so that's going to give me to the 2.1 going from the left. And on the right one, if we could do the same thing, we go all the way down and we see it's going to be 2.1 from the right as well. And so what I will do now is I will copy this so we can take it and put it back over in our PowerPoint. And let me think here. What's the other question? Numerically, it doesn't ask for the percent rock, so I don't think we need to worry about that this time. All right, so let's go ahead and paste that in there. And so let's see, we've got A, that's up here. B, we aligned it, found a quadratic. Oh, well, actually A is just, we saw is concave down, so we better write this one down for A. Concave down. Basically has a change of direction, increasing, and then decreasing. Then we have, again, part B. That's going to be here. So this is B. That's our function. And then this whole thing is basically our C it's asking for. And so C says, what is S prime of 7? Well, that's going to be approximately 2.1 thousand dollars per year. Okay, and so that would be what C is. And D, I think there was a D, interpret the answer to part C. All right, well, D, maybe we should do over here so we can have more room to write. And so basically with D, we're going to have in 2007, because that's when they want it for. Let's see, this is the average weekly sales. For A and F, we're increasing by, now let's just put it as the whole number because we're not going to put 2.1 thousand, we'll just put $2,100 per year. Okay, so that would be what the average weekly sales are going up by, that $2,100 per year. Yeah, per year. All right, let's see. So I think we have all that one answered. So let's stop there and we'll come back for more.